A series of magnets is placed under a glass pane and some iron filings are sprinkled onto the glass. The orientation or slope of the iron filings, as determined by the magnetic field, is shown below. One of the lines of magnetic force that passes through the point A01 is also shown. We're told that the slope field is given by dy dx is 1 over 2x minus 2. Determine the value of the slope field at A01. So here x equals 0. So dy dx evaluated at 0, 1 is just going to be 1 over 0 take away 2, which is negative a half. We now want to explain the orientation of the iron filings at x equals 1. So x equals 1, we can see that what we've got here, it's very difficult to see actually on this, but what we've got are vertical lines on the tangent field, and that's because the denominator is 0. So the denominator is 0 and the gradient is therefore undefined. Determine the equation for the line of force that passes through the point 0, 1. So that's the one that we actually have. So dy dx is 1 over 2x minus 2. So the integral of dy is equal to the integral, or half the integral of 1 over x minus 1. Just take the 2 out. So that gives me y is a half natural log x minus 1 plus a constant. Now we know that y equals 1 when x equals 0. So 1 is going to be a half ln 0 take away 1 in modulus plus c. Well, this becomes ln 1, which is 0. So that means that c is equal to 1. So I've got y is equal to a half ln mod x minus 1 plus 1. The answer in the mark scheme is slightly different. It's actually the same, but written differently. We've got that, and then they've got a different c. But you've got to remember here that I can write that as ln 2 x take 1, which is ln 2 plus ln x take 1. So the 2 in here ends up being part of the constant, which is why their constant is different to my 1. So both answers are actually correct.